Hey guys, today we're going to be talking about sig figs again. This time, instead of focusing on, counting sig figs, today we're going to go right into dealing with math problems and kind of how to figure out sig figs with that. What you'll notice for the quiz today, and you'll notice for this specific problem, is that, or sorry, the daily assessment for today, is that you'll notice that this number over here, 9,840, has three significant figures versus 34 only has two significant figures. So how do you deal with finding an answer and figuring out its sig figs? Because the numbers in and of themselves have two different sig figs. Thing number one I'll say about this is bad science. It's bad science to have one measurement. For example, the 9,840, it has three sig figs, so it would be a more precise measurement versus the 34 is a less precise measurement. So it's bad science to have two different standards for how accurately you're measuring something. That being said, it does happen. So just be aware of that. Okay, first rule is to just do the math as normal, right? So in this case, you're going to take the 9,000 number and you're going to multiply it by 34. And when you do that, you get 334,560 as your answer. Really big number, right? Now, the next step is also the last step. And that has to do with sig figs. So, right, we know this guy has three, we know this guy has two, and we're just going to round our answer to the least number of sig figs. So if we're rounding our answer to two sig figs here, because two is our least number of sig figs, we're going to keep the 3 and the 3, and then the 4 comes after it. So in this case, 4 is less than 5, we round down. So our answer is going to be 330,000 as our final answer. We only keep these first two 3s. Everything else gets changed to zeros to represent that we have two sig figs in our final answer. That's it. Now, sometimes people get kind of confused with this. They're like, well, why can't the answer have three sig figs? Why can't it have, sometimes they'll get even more confused and they'll be like, maybe since we're multiplying, it should have five sig figs, adding the sig figs together. Maybe it should have six. Since you're multiplying, you should multiply sig figs. With that, it's kind of helpful to remember that these are measures of uncertainty, right? We're saying that we know in a three sig fig number, we know the 9, the 8, and the 4, for example, but this 0 number isn't necessarily a value of 0. It could be a number of anywhere from like 1 through 5, kind of depending on where you want. It could be as high as 4, 4, for example, or it could be as low as 3, 5, and we would still kind of round it up. If that makes sense. And then same thing with 34. 34 could have a decimal after it. And that number could be like 4.5. It could be 3.5, and we would still round it to 34. So that's actually what I'm going to show you on the next slide. Is kind of why we say that you're only as good as your weakest link. You're only as good as your least number of sig figs. So hopefully this helps. If it doesn't, just know round your answer to the least number of sig figs always. That's kind of the rule to remember, but it can also help to have some explanation. So yeah, sorry, we're gonna skip past this for a quick sec. Okay, so the question is, why do we take the lowest number of sig figs? So this is the same problem that we just did. Oops, and remember this was the answer, of course. Now, all numbers in science have margins of error. What that means then is this 904 or 9,840 could be higher or it could be lower, right? Depending on what we're using to measure. Imagine for a second that you're measuring this, that not this is a number given, but maybe you're measuring it by looking at a beaker or something like that. It might be hard to figure out exactly which line it's at. So you're like, well, I can get the first three numbers, but the fourth number, it's kind of hard to tell. What I'm saying then is that this number could be as high as 9,844, right? This would still round down if we put it into, currently these numbers are both in more than three sig figs, but if we changed it to just three sig figs, we would get 9,840 in both of these cases. And this is about as low as you can go. If you go any lower, then it rounds down to 9,830, for example. There's also a range for 34, right? 34 could be 34.4, and it would still be 34 if you rounded it down to two sig figs, or 33.5. That's about as low as you can go and still have it round up to be 34. Now, those are the ranges of the individual numbers. But then if we multiply these two numbers, the two highest possible numbers we can have, and we multiply the two lowest numbers we can have, we're going to get pretty different values than our answer, right? Our answer was 334, and we're seeing numbers like 338 or 329, right? So it's kind of a bummer that you have to take all the numbers here and then just keep the first two. But it turns out that that's what you're supposed to do, just because if you keep the first two, you'll notice that they're fairly similar, right? Rounding this answer in blue to 2 sig figs, we get 340,000. Rounding this answer in red to 2 sig figs, we get 330,000, which if you remember from the previous slide, when we actually round our final answer to 2 sig figs, we get 330,000 as well. So 330,000 looks very similar then to these two answers. Again, this being a higher number, it's very possible that it could actually be a little bit different. So, yeah, this is really all to say that with a low number of sig figs, you can really truly have a wide range of possible answers. So that's why if we're multiplying something with a lot of sig figs by something with a little bit of sig figs, we want to have our final answer have the little bit of sig figs, because otherwise our possible answers could be really different. And we want to be aware of that. We want to make sure that that doesn't happen. So yeah, if this is confusing to you, what I hope is not confusing to you is round answer to the least number of sig figs. I hope that's not confusing in terms of what I want you to actually do, like on the daily assessment for today. All you have to do is know how to do that. If you know how to do that, that's awesome. But if you don't know, if you know why, that's even better. Okay, I'm going to go back here and go through a couple practice problems of using this skill, right? Okay, so in the first question, we have 63 times 105. In the second question, we have 611 divided by 9.1. This is, so we use the sig fig rule of least number of sig figs for multiplication. We use it for division. I'm going to go ahead and do the math for you in this problem, just so you can kind of see there's no tricks I'm pulling. It's all just kind of, keep it all above board. When we take 63 and multiply it by 151, we get 9,513. Now, remember, we have to look at sig figs of our numbers that we start with, and our lowest number is 2, so our final answer has to have 2 here. So it's 9,500. That's our answer. Kind of cool. For the second one, 611 divided by 9.1, we get 67 point tons of decimals. Now, the nice thing about sig figs here is that you won't have to write out all these decimals in your final answer. You just have to write out, in this case, the first two numbers, because 9.1's got 2 sig figs. So we're just going to keep the 6 and the 7, and because it's a 1, yeah, it just stays 6, 7. So it'll be 67 is our final answer. Kind of cool here. Okay, one other problem that I did is a density problem. Density, as you might recall, is mass divided by volume. So here I give you a mass with a ton of sig figs. This would have been measured on an analytical balance. And then the volume of water is just 40 milliliters. Look at that. That 40 milliliters has 1 sig fig. That means it was probably measured with a beaker or something really, really inaccurate. So you take a really, really accurate mass measurement and a really, really inaccurate volume measurement. That's bad science, right? So let's get that out of the way first. It's bad science. You should probably use the same general level of accuracy for both measurements. That being said, though, we can really only report our answer with 1 sig fig, right? Now, that looks kind of dumb when we actually do density. Density, we're going to take this 34 number and we're going to divide it by 40. And when we do that, the calculator spits out something like 0.8697, right? And you're like, oh, that's kind of a nice number. Maybe we can round it to 2 sig figs. But no, we've got this stupid 40 milliliters over here, which means we can only round it to 0.9. That may seem lame, right? That might be like, oh, we should really, it kind of looks like this just 1 sig fig looks really dumb. It looks like there should be another sig fig there. Unfortunately, there's not. And here's why, right? Again, what I'm going to do is I'm going to take, okay, this number, it could be as high as having a 4 after it, 3.4, or it could be as low as 2.5, and it would still round to this number in bold up top here. And then I can do the same thing with the volume. To round it to 1 sig fig for 40, it could be as high as 44, and it round down to 40, or it could be as low as 35 and it would round up to 40. And then if you take the high numbers and the low numbers, you kind of get a range, and that range is anywhere from 0.79 to 0.99. So again, very, very wide range of possible answers here. And the problem here is that volume measurement had pretty much one sig fig, so like no real accurate information. So again, the key is you have to round to your least number of sig figs. That's key number one. All right. That's really the only thing you have to know for today. And the reason is you can't report this number in 2 to 4 sig figs because these numbers over here have such a wide range. They could be so different. Yeah. Key for the day, folks, round the answer always to the least number of sig figs. It's never, you don't ever, if you have multiple numbers, you don't average them out. If you have numbers with multiple sig figs, you don't add them, you don't subtract them, you just round them. All right. I hope this helps. I hope you guys are feeling great about this information. Have a great rest of your day. We'll see you next time. Take care.